Welcome to Takno Mastr. Today, we are going to dive into a highly requested and incredibly practical project. If you've ever found yourself needing a highly specific voltage for a project and scrambling around for the exact right battery or wall adapter, well, this explainer is exactly what you need.
So here is the big question for you. Want to convert any voltage from 3 volts to 40 volts into an adjustable 1.25 to 37 volts? With just one LM317 IC, you can build your own variable lab power supply. It sounds almost too good to be true, right? But it's completely possible. And better yet, it's a breeze to put together. Let's build it.
Okay, let's dive into this. In this explainer, I will show you how to make a simple LM317 adjustable power supply circuit with a fully explained circuit diagram. Here is our master plan. It's a nice, clean, easy-to-follow layout showing exactly how this whole thing is going to come together.
Section 1. Gathering your components.
Before we start soldering any wires, we gotta gather our ingredients. And what's really wild here is just how minimal this parts list actually is. For this project, you will need an LM317T voltage regulator IC, a 5K potentiometer to adjust our voltage, a 220 ohm resistor, a 470 microfarad 50 volts capacitor, a 1N4007 diode, which acts as a nice little safety net, and a dot PCB to mount it all on. That's literally it, just a handful of components to create a massive upgrade for your workbench.
Section 2. Wiring the circuit diagram.
Now that we have our parts ready on the workbench, don't let schematics intimidate you. The circuit is very simple. We're going to take this step by step. This perfectly illustrates exactly where every single leg needs to go. The absolute heart of this entire operation is that LM317 IC right up there.
Let's look really closely at the pins on that IC. Pin 1 of the LM317 is the adjust pin, which gets connected directly to the potentiometer. This is how we literally dial in our voltage. Next up, pin 2 is the output pin in the middle, which will give us that sweet 1.25 to 37 volts adjustable output. And finally, pin 3 on the right is the input pin, where we will give 3 volts to 40 volts DC input from whatever our initial power source is.
So what about the rest of the board? Understanding what those supporting components are doing is totally key. The 220 ohm resistor is connected between the output and adjust pins specifically for voltage stability, making sure things don't jump around wildly. The diode is there for reverse polarity protection, saving your circuit if you ever hook things up backward. And the capacitor is just for filtering the output, smoothing out the signal so we get nice, clean, reliable DC power.
Section 3. Testing the variable output.
We've wired it all together, and now comes the absolute best part of any electronics project, firing it up. Now, when I connect a 12-volt input and rotate the potentiometer, you can see on the multimeter the voltage is changing smoothly from 1.25 volts to almost 11.5 volts. It's incredibly responsive. But check this out. If I give 24-volt input, I can get up to 37 volts output easily.
37 volts, that is a massive range of utility from such a tiny, inexpensive little circuit. Whether you need 3.3 volts for a microcontroller, 5 volts for some logic chips, or 12 to 24 volts for a big motor, this one board completely has you covered.
Section 4. Your new testing tool. You have successfully taken a handful of basic components and transformed them into a legit piece of lab equipment. This is perfect for testing any electronic circuit because you're no longer limited by fixed voltage wall adapters. So this is absolutely a must-have tool for every electronics lover, from total beginners to seasoned pros.
I really hope you enjoyed following along with this build today. If you like this project, please like, share, and subscribe to Takno Mastr for more electronics projects. Thanks for watching. Your support is literally what keeps this explainer going.
But right before you go, I want to leave you with one final thought. Now that you have a fully functional variable lab power supply sitting right on your workbench, what electronic circuit will you build and test next? The possibilities are endless. Get out there, start building, and I'll see you in the next explainer.